Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Welcome to another class of compiler. Yes guys, am I properly audible and visible to all of you? Please let me know once in the chat box. And guys, do like the session, share with your friends as much as you can so that we can have maximum students and they can take the benefit of these classes. Yes, please confirm once in the chat box. Am I properly audible? Okay, thank you, Vishal. Good evening all of you. Yes, good evening, Kirutika. Welcome. Yes, guys, everyone like the session and share as much as you can. So today the topic is going to be syntax directed translation, that is SDT, which is we can say a part of semantic analysis phase. Basically, semantic analysis phase uses SDT. So we are going to discuss the most important concepts of this phase. Good evening, Ikra. Good evening. Welcome. Yes, just give me a minute. Yes, thank you. Thank you. Okay, fine. So yes, so let's start this session. Right. So we have started concept capsule series where we are going to provide you a short video of 10 to 15 minutes. Okay, and there you will be getting all the GATE fundamentals and tricks. So we are going to provide it. For computer science, it is going to be every Sunday and Thursday at 9 a.m. and this is going to be the schedule for other branches. Okay, every Sunday and Thursday at 9 a.m. Good evening, Divya. Welcome. Homework questions attempted, Vishal. Okay, that's good. I'm good, Divya. How are you? So before starting, those who don't know me yet, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience in GATE. 2020, I have secured All India rank 294, cleared ISRO and NEET exams, mentored more than 1,000 students as of now, and these are my area of expertise. Okay, fine. So today we are going to directly start with the topic. We are not going to solve homework questions because that will consume a lot of time, right? So we are going to directly start with the topic. Also, if you haven't joined my Telegram group yet, so you can join this through this link. This is the link of my Telegram group. You will be getting all the PDFs of my technical classes. Also, if you have any doubt, you can ask your doubts there. And if you need any guidance, then also you are most welcome. Yes, Divya, आपका पढ़ाया हुआ सारा समझ आता है. Thank you. Keep learning, keep attending the classes. Good evening, good evening. Saubhagya, welcome. No, WhatsApp group is not there, only Telegram group is there. Okay, so you can join through this link. Fine. So this is the schedule for this compiler design. So already we have covered these classes and today we are going to start syntax directed translation. After that we have 2 more classes. One is for intermediate code generation and other one is going to be for liveness analysis, which is very important topic. Yes, Kirutika, concept capsule will take after compiler design topics. Concept capsule series already started. So if you just visit this channel, BYJU'S Exam Prep YouTube channel, you will be getting that. Okay. So one video is already uploaded by Satya sir, right? Next video is going to be uploaded by mine. I will be uploading that from Digital Logic. Okay. One topic will be there from Digital Logic, so you can watch that as well. So on Thursday, on this coming Thursday, it will be uploaded. Clear? Good evening, Sashikala. Welcome all of you. Okay, no, WhatsApp is not that comfortable. Telegram, it is more comfortable than WhatsApp, right? Fine. Let's proceed. So today we are going to talk about the semantic analysis phase. So I hope all of you have already solved the homework questions. We are not going to discuss those questions today because we have a lot of things to cover today, right? So the third phase of the compiler, which is your semantic analysis phase, or we can say semantic analyzer. So it is going to take the input as the parse tree, which is going to be generated by the syntax analysis phase, and it is going to generate output as your annotated parse tree, you can say, or semantically verified parse tree. Okay. So as you can see here, semantic analysis makes sure that declarations and statements of program are semantically correct. For example, if you are writing something like this, let's say int x, right? So it is going to check the data type. That means all the type checking of the expressions, type checking of thank you, So type checking of the variables and type checking of, so please focus on the class, fine. Type checking will be done by the semantic analysis phase for the expressions and for the statements, right? And we will see a lot of examples as well. Apart from that, there is more functionality of semantic analysis phase. Now, let's see the functionality one by one. Type of each identifier is identified and it makes an entry into the symbol table. So, like okay, later on or maybe in the next class, I will let you know the answers, okay, Ritika? Okay, or I will share in my Telegram group, I will share the answers, okay? Then you can match your answers, fine? Now, the first functionality of this semantic analysis phase is, it is going to identify the identifiers, type of each identifiers, and it is going to make the entry into the symbol table like lexical analysis phase and syntax analysis phase. Clear? The second thing we have is type checking of the expression. So if you are writing any expression, for example, let's say you are writing int x semicolon and x is equal to y. Now here it is going to perform the type checking of this expression. As you can see, already we have defined this int x and the type is integer. So it is going to check the type, data type of y as well. Then only we can perform the assignment, right? So type checking of the expressions and function capability like return type, parameter type, number of parameters, all these will be checked by your semantic analysis phase. Good evening, Tushar. Welcome. And the last thing is declaration checking of identifiers before its use. As you can see here you can see we are using y but we haven't declared it, right? In that case, it is going to throw the warning or it is going to throw the semantic error. Clear? Now, let's understand this through one example. Let's say here you have a main function int x, x is equal to y. Now, here you can see in the symbol table, we have these lexemes x and y. We are talking about this x and y. We are writing the types also. So this semantic analysis phase is going to write the type of every variable we are using. So here x is integer type, so it is making the entry, right? It is going to identify the type and it is going to make the entry into the symbol table. And token, that will be done by your syntax this lexical analysis phase and then line number. Now here we are using x is equal to y. That means we are assigning the value of y into x. So when this statement will be executed by your compiler or will be compiled by your compiler, in that case it is going to check the type of y. And you will see here that there is nothing defined. There is no entry related to the type of the variable. So in that case, it will throw the semantic error. Semantic error will be thrown. That is, y is not defined. Because if y is not defined, we cannot compile the statement, right? Both has to be of same data type, then only we can perform the assignment operation here. Is it clear to all of you? Is it clear to all of you? If you have any doubt, please ask. All clear so far? So in this way, it is going to throw the error that y is not defined. Clear? Now let's see this example. Here we have one function and we have two parameters for this function. One is integer a and other one is integer b. Yes, that is the thing. Now here we are calling this function. So this is function calling and the above one is your function definition. This is your function definition. Clear? Now whenever you are calling the function, so it is going to match these parameters. These are actual parameters and these are formal parameters. So this is going to be matched with this type of like the type of this actual parameter will be matched with the type of this formal parameter. Both are integer type. So that is fine. But what about this one? Here you have a float value and you are giving this to an integer type. So here type mismatch will be there. So that is why it will be your semantic error and that will be type mismatch. I hope you are getting this. This is also a semantic error. So function return type will be checked also. Function parameter type, number of parameters, everything will be checked by the semantic analysis phase. Is it clear so far? Everyone, if you have any doubt, please ask. Clear? So type mismatch will be thrown as the error. Now here we have 3 questions. So this we have already seen. That is y is not defined, right? This kind of error will be thrown. What about this one? What about this one? Will there be any semantic error in this second example? Tell me. Will there be any semantic error in this second example? What do you say? Here we have int x and we are assigning a float value to integer x, right? So in that case, again it is going to throw the error which is type mismatch. Type mismatch. And what about this one? The same thing, function is calling and here we have integer value. So here it is going to be mismatch. We can say parameter mismatch. Parameter type mismatch. Clear? So all these are examples of semantic error. Yes, parameter type mismatch will be there. So these are the examples of semantic analysis phase and what kind of errors it may throw. So these are the examples. I hope it is clear. Now let's proceed to our main thing, that is SDT. See, SDT is way more powerful than semantic analysis phase. Using SDT, you can implement the entire compiler as well. Okay, why I'm saying so? Because in SDT we have the grammar. Grammar is already there, that is context-free grammar. But apart from that, we have the translations as well. Now this translation can be anything. This translation can be semantics. This translation can be any action that we want to perform. It can be a rule, it can be a program, output, evaluation, and produce intermediate code. Apart from that, it can be anything. That means if I'm writing this as a program, that means you can write any program. You can write the entire compiler program as well. So using this SDT, you can implement any phase of the compiler. You can implement lexical analysis phase, syntax analysis phase, ICG, because it can produce intermediate code. So you can use this SDT as generating intermediate code as well. Similarly, you can use it for all the phases of the compiler. So SDT is way more powerful than compiler itself. I hope you are getting this point. But to have reusability, we are dividing our compiler into multiple phases so that we can use every phase and we can use the front end for the different type of machines. Clear? If we want to design a compiler for, let's say, C language, and we have 5 different machines. So in that case, the first 4 phases we don't have to implement again and again. I hope you are getting this point. First 4 phases we don't have to implement again and again. So this is the concept behind this reusability or having multiple phases of the compiler. Clear? So we can implement this compiler using SDT also, but again we want to have reusability. That's why we are just using SDT for this semantic analysis phase. Is it clear so far? If you have any doubt, please ask. All clear? So this translation can be any of these and way more than that, right? Clear? This is just an example I have given here. Now we are going to understand this through one example. So in SDT is equivalent to the context-free grammar plus the translations associated with the productions. Now carefully see this. This is one example. S derives AB, A derives small a, B derives small b. Now these are the productions that you are having. Now for every production you are having some translation associated with that. Clear? Now this translation can be anything. You can perform some action, like here you are just printing 20. So you can print 20, right? Here you are assigning some values. So let's say S is having some attribute X and it is taking the value of attribute of A plus attribute of B. So here we can have the attributes associated with the non-terminals as well as the terminals. Clear? And this translation can be anything. It can be this, the semantics, it can be the actions, it can be the rule, or way more than that. Now here A derives A dot X is equal to 50. That means just we are assigning the value 50 to the attribute of A. Similarly here we are assigning 10 to the attribute of B. So this is the example of SDT where we have the context-free grammar plus the translations. Is it clear, everyone? So using this example, you can see here A is taking the value 50, B is taking the value 10, and we are adding the value of A and B, so which is finally going to generate 60 as the output. So in these translations, you can write anything. Clear? And guys, do like the session if you haven't liked it yet. Now, the most important thing we are going to start now, that is inherited attribute and synthesized attribute. So we have two types of attribute, one is inherited, other one is synthesized. Now carefully understand the difference between these two. In case of inherited, let's say this example. First we are going to see the example, then we are going to see the definition. S derives AB. This is the, let's say this is the production given to you. Now here if you see, B, the attribute of B is taking the value from S and A, right? That means B is taking the value from S and B is taking the value from A. Clear? When your attribute yes Ikra, I have problem in finding sequence. Okay, it's okay, I will take some examples and it will be clear to you. Now carefully see this. B is taking the value from S as well as A. So in case of inherited attribute, the attribute can take the value from its parent and or from its siblings. Now it can be the left sibling, it can be the right sibling, both are allowed. Now see the definition. An attribute is said to be inherited attribute if its parse tree node value is determined by the attribute value at the parent, clear, and or siblings node. That means A can take the value from S, which is its parent, A can take the value from its right sibling as well. Similarly here, as you can see here, B is taking the value from its parent and B is taking the value from its sibling. So if we have these kind of attributes, we can say that attribute is, that X attribute is your inherited attribute. Is it clear, everyone? I will be taking so many examples, so don't worry, everything will be clear to you, crystal clear. Now let's talk about a synthesized attribute. Now in case of synthesized attribute, you can see here, this is the production you have. Now here S is taking the value from A. S is taking the value from A. That means it is, the parent is taking the value from its children. The parent is taking the value from its children. So in case of synthesized attribute, attribute is said to be synthesized if it is taking the value at the child nodes. That means it is taking the value from its children. So in that case, we call those attributes as synthesized attribute. Any doubt, anyone? If you have any doubt, please ask. All clear? Yes. Please confirm once in the chat box so that we can proceed, because then we have the examples. We are having examples so that we can understand these concepts more clearly. Yes, examples are here. Don't worry, Vishal. Now let's talk about this first example. Now here you have to tell me whether this X attribute is your synthesized attribute or inherited attribute. So let's see here. S drives AB, A dot X is equal to B dot X. Now carefully see this. I will be solving one or two examples, then you can solve it. A is taking the value from B and B is sibling of A. So can we say that X is your inherited attribute? Yes or no? Can I say here X is inherited attribute? Is it clear? Similarly, let's talk about this second example. S derives AB. S is taking the value from A and B. S is taking the value from A and B. That means S is taking the value from its children. S is taking the value from its children. So we can say, so far we can say that X is your synthesized attribute, because in case of synthesized attribute, it can take the value from its children. Yes, Shashikala, any doubt? Any doubt you are having? Tell me the example number so that we can discuss again, okay, if you have any doubt in any of these. And here if you see A dot X is equal to 20, that means here it is not taking the value from children or parent, nothing like that is specified here. So just on the basis of this first production and its translation, we can clearly say that X here is synthesized. X is synthesized attribute. Yeah, it is not mentioned, that is fine. It is not mandatory to have parent attribute also. Like in translation, we can do anything. It's not like every time a parent is going to be involved. No, in translation, here we are writing that A is taking the value from B. That is allowed. We can have any translation associated with the productions. It is not mandatory to have the parent involved every time. Is it clear? If you have any doubt, please ask. Now what about this one? Yes, everyone try to find it out and let me know whether here X is your synthesized or inherited attribute. Guys, like karo yaar session ko, those who have joined just now. And also share this session with your friends and juniors, those who are preparing for GATE 2023 and 2024. So that everyone, those who are not aware of these sessions, they can also get the benefit. Yes, Ikra is saying inherited, Vishal is saying inherited. Yes, Kirutika inherited, and one more time explain please, sir. Okay, let me explain you. See, carefully see this, everyone. When I say inherited attribute, that means, let's say here, S derives, let's say AB. Now here if I'm writing, A, let's suppose A dot X is equal to S dot X. For example, I'm writing, right? Let's say this is one production, this is one translation, and other translation I'm writing is, let's say this. B dot X is equal to A dot X. For example, I'm taking this, right? Now here you can see in case of inherited attribute, either the attribute value can be taken from the parent, right? Or it is going to be from sibling. Sibling can be left also, sibling can be right also. Both are allowed in case of inherited. Clear? And it can take the value from parent as well. So that is your inherited. When the attribute is taking the value from its parent or from its sibling, then it is inherited attribute. I hope it is clear now. And what about this one? Okay. What about this synthesized attribute? Here, if the parent is taking the value from its children, in that case it is synthesized attribute. Clear? Now, let's talk about this third example. Everyone. Is it synthesized or inherited? Yes, what do you say? Is it synthesized or inherited? Yes, guys, do like the session. I can see just only 8 likes and 16-17 students are attending. Okay, Kiritika is saying inherited, Sashikala inherited. It is both, so it is neither nor. It has both attribute. Okay, let's say this. A is taking the value from S and B. A is taking the value from its parent as well as its sibling. So far we can say X is inherited. So far we can say based on the first translation that X is inherited. But if you see this one, next one, A is taking the value from B. A is taking the value from B. That means it is taking the value from its children. Now we have the conflict. We have the conflict because based on first translation, it should be inherited. But based on second translation, it should be synthesized. So it is neither inherited nor synthesized. Is it clear? Is it clear to all of you? It is neither inherited nor synthesized. Okay, sure, Vishal. If you want to do that, it's fine. What about this one? Example 4. Vishal is having doubt. Yes, tell me. What about example 4? Here we are talking about attribute X. Is it inherited or synthesized? Tell me. We will see that example as well. Wait, Vishal, we will see that example as well. Your doubt will get clear. Just wait for a few minutes. Yes, Sobhagya is saying it is synthesized. Okay, Sakshi is saying it is synthesized. So here if you see, S is taking the value from A, S is taking the value from A. So clearly we can say it is taking the value from its children. So X is synthesized. Clear? What about this one? Example number 5. What about this one? Fifth one. Here A is taking the value from S. A is taking the value from S. That means it is taking the value from its parent. And here we are not having any translation. So we are not going to consider that. Just on the basis of this, we can clearly say that it is taking the value from its parent. So it is inherited. Exactly. X is inherited. X is inherited. What about this one? What about this one? Example number 6. What do you think? Yes, that is correct, Kirutika. Example 5 is correct. What about 6th one? B is taking the value from A. B is taking the value from A. And A dot x is equal to 10. Inherited. So here B is taking the value from A, that means it is taking the value from its sibling, and here A dot x is equal to 10. So we are not going to consider that because it is assigning just the constant value. So on the basis of this, we can clearly say that x is inherited. X is inherited. What about this one? 7th example. What about this one? 7th. B is taking the value from A dot x is equal to A dot value, B dot x is equal to B dot value. See, whenever we talk about inherited or synthesized, we talk about the attributes, not the non-terminals. Okay, remember this thing. We are talking about attribute. Is it clear, everyone? So let's talk about the 7th one. B is taking the value from A, taking the value from sibling. Here it is taking the value from children. Now what do you say? It is both. So Bhagya is saying, okay, 8th example, fine. So here it is taking the value from its sibling, that means it should be inherited. Here it is taking the value from its children, that means it should be synthesized. So it is neither inherited nor synthesized. Clear? What about this 8th one? This is very interesting. What do you say about 8th one? So Bhagya is saying it is both. Yes, everyone. S dot x is equal to 10, constant value. A dot x is equal to 20, constant value. What do you think? So in these type of examples where you cannot decide whether it is synthesized or inherited, then in that case you can clearly say that it is both. Yes, it is both. Only in these type of examples you can say it is both synthesized and inherited. Otherwise you cannot say. Otherwise you cannot comment on that. No, whenever you are not having any clarity, so you can say it is both. Clear? Only in these examples where you have nothing to decide. Clear? But when you can decide, then you can clearly say whether it is neither or nor, or whether it is inherited or synthesized. Is it clear? Fine. Let's talk about this one. Last example. Now here you have two attributes. One is x and other one is y. So you need to find out x is inherited or synthesized, y is inherited or synthesized. Carefully say this and let me know. This is the last example. After that we are going to proceed to the next concept, which is the definitions. SDT definitions. That is the most important concept of SDT. Yes, what do you say about example 9? Here you have two attributes, x and y. So carefully see this and then answer. X is synthesized. Okay, Nishu is saying x is synthesized. What about y? Y is inherited. X is synthesized. Y is inherited. Okay. Let's say this. S is taking the value from A. S is taking the value from A. That means it is taking the value from its children. Let's talk about x first. A dot x is equal to A dot value, children. B dot x is equal to B dot value, children. So that means x is synthesized. X is synthesized. What about y? B dot y is equal to A dot x. B dot y is equal to A dot x. Taking the value from its sibling. A dot, these are constants, so no need to consider them. Just on the basis of this, we can say it is inherited. It is inherited. Clear? Yes, that is correct. Fine. So now let's talk about S attribute and L attributed grammar. This is very, very important concept. So carefully listen this and then make your notes if you want to. Clear? So let's understand the difference between these two definitions, SDT definitions. One is your S attributed, other one is your L attributed. Most of the students, they get confused between the attributes that we have discussed so far, that is inherited and synthesized, and the grammar. So these definitions, both are different. So carefully listen this and pay attention. L attributed grammar and S attributed grammar. The first point we have in L attributed grammar is attribute computation. Here in this case, L attributed depends on parent and or left sibling and or children. Clear? So here attribute computation depends on parent and or, that means you have the choice, or you can have both. Left sibling, here right sibling is not allowed. Here right sibling is not allowed. And or children, that means either you can have children or you can have all. Clear? Now if we talk about S attributed grammar, attribute computation depends only on children, no parent involved. So you can consider this as almost same as synthesized attribute. Clear? Because in case of synthesized attribute also, the attribute computation depends only on the children, but here also it is depending on children value only. But L attributed is different, because here you can have parent, here you can have left sibling and children as well. Clear? Now the second point, I will be taking examples also, don't worry about it. Second, translation can be present anywhere on the RHS. For example, let's say this one. You can have something like this, you can have something like this, you can have something like this. That means the translations can be present anywhere on the RHS. It can be present in the beginning, it can be present in the middle, it can be present at the end. This is about L attributed grammar. So to identify whether the given grammar is with given SDT is L attributed or S attributed, so this is very important point. Just on the basis of translations positions, you can also identify it. Clear? Clear? Now what about S attributed? Translation can be present only at the end of the RHS. That means you are going to have something like this. This is allowed only. That means always the translations will be present at the end of the RHS. Clear? Let's see the third point. This is also important. Evaluation. Now here, if we have to evaluate the expressions or the SDT, then depth first, left to right. So first we are going to follow depth first, and then from left to right we are going to proceed for the evaluation purpose. Carefully listen this, okay? And what about S attributed? That is bottom up parsing. Bottom up parsing means reverse of RMD. Bottom up parsing means reverse of RMD, reverse of rightmost derivation we are going to follow for S attributed grammar. All clear, everyone? Now carefully understand this point. Carefully understand this point. We have something common between this L attributed and S attributed. What is common? Here attribute computation depends on children, and here also we have attribute computation depends on children. Here we can have translation anywhere on the RHS, so we can have this case also, and here we have this case only, that translation is present only at the end of the RHS. That means, can I say if a grammar is S attributed, definitely it will be L attributed. Can I say so, everyone? If a grammar is S attributed, definitely it will be L attributed grammar, or the SDT basically. Are you getting this point, everyone? Because these 2 points are common, right? At the end of the RHS, and at this computation depends on children. So definitely if we want to establish the relation, so this is going to be the relation. If a grammar is S attributed, definitely it is L attributed. If a grammar is L attributed, it may or may not be S attributed. And if a grammar is not L attributed, it can never be S attributed. Is it clear? Now it's time to see the examples, and on the basis of examples we are going to identify whether the given SDT is L attributed or S attributed, or both, or whatever it is. Now this is the first example. This is the first example. What do you say? Is it L attributed or S attributed? First example, example 10 you can say, here numbering is such like that. Okay, tell me. Example 10. Is it S attributed or L attributed? Everyone. अरे डिविलियर्स निशु क्या कर रहे हो? Translation. In case of S attributed, translation will be present only at the end. Here it is present in the beginning. So we can clearly say it is L attributed. It is L attributed only. It is not S attributed. Okay. Write this point also. Only. Not S attributed. Fine. What about this one, 11th? What about this one? Here if you see, translation is present at the end of the RHS. So that is allowed in case of S attributed as well as L attributed. Correct? Now here if you see, it is just assigning the constant value. So we cannot, we cannot consider the attribute computation. Here we cannot decide that. So we can clearly say it is S attributed. And if it is S attributed, definitely it will be L attributed as well. That means it is both. It is both. Clear? What about this one? Example number 12. Here you can see translations, all the translations are present only at the end of the RHS, right? That means it is common in S attributed or L attributed as well. Now we have to see what? We have to see the attribute computation. Here if you see, A is taking the value from B. A is taking the value from B. What do you say? What about this 12th one? Is it L attributed or S attributed or neither nor what it is? So Bhagya is saying it is neither L attributed nor S attributed. Yes, anyone else getting the answer? Sakshi is saying L attributed. See here, translation on the translation position we cannot decide, but here A is taking the value from B. That means it is taking the value from its right sibling. Is it allowed in case of L attribute that attribute computation can depends on the right sibling? Tell me, is it allowed? It is not allowed. It can take the value from left sibling only, or parent or children, not the right sibling. So that is why here it is taking the value from its right sibling. So it is neither L attributed nor S attributed. That means this is the example. It is lying here, right? It is neither L attributed nor S attributed. Is it clear? Is it clear to all of you? Fine. So now we have covered the examples based on L attributed and S attributed. Now we are proceeding towards the evaluation part. That is the last point. So here we have this example. This is basically a previous year question. If you have solved previous year, you can easily identify. This is a previous year question. We have the SDT given to us, the grammar and the translations associated with that. Clear? And we have this given input. Now we need to find the output. Yes. Now carefully understand this point. In the question, if it is not given whether you have to use the bottom up parsing for evaluation or the this one depth first left to right. So first identify whether it is L attributed or S attributed. Now if you carefully see this is basically all the translations are present on the end of the RHS. That means it can be both, and here we are not having any attribute computation, so we can clearly say that it is both S attributed and L attributed. It is both S attributed and L attributed. Now if it is both S attributed and L attributed, in that case we can use bottom up parsing as well, or you can use depth first left to right. Now which one is more easier to evaluate? Depth first left to right. That means L attributed computation or the evaluation is much easier than your bottom up parsing, which is reverse of RMD. Clear? So now let's solve this question. Carefully see this. This is the input. On the basis of this input, we are going to make the tree here. So here we have this S, which is going to derive X, X and W. Now let's number these translations. Let's say this is first one, this is second one, and this is third one. We are numbering these translations. I will tell you why we are numbering this. Carefully see this. First double x is done, then we have we need two more x, then y double z. So from w we can generate sz. We can generate sz. Now from x again we can generate this one because we need 4x. 2x is here, 2 more x we can get here. Clear? So 4x are done, then we need y and z because 1z is already there, so we need y and z. Now from this w we can get this sz, right? So 2z's are done, 4x are done, now we need y. So from s we can derive y also. So here it is going to be y. So far is it clear? You have to make this tree, parse tree, then only you can solve this question correctly. Clear? Now carefully see this. Telling you the shortcut, direct shortcut, okay? Carefully see this. We are following depth first, left to right. You can solve this question based on bottom-up parsing as well. If anybody wants me to solve this question based on bottom-up parsing, reverse of RMD, you can let me know in the chat box. I will do it. Now carefully see this. Depth first, left to right. So if I go depth first, I will reach here, right? I will reach here. Now S derives Y. S derives Y. That means this one. I have the translation here. Let's take it downwards below this line. Let's take it downwards. Just make an arrow below this line so that you can get the order in order to evaluate, right? So this is the first arrow we are going to get. After this, left to right. Depth first is done. Left to right. Then we have SZ. W drives SZ. Then we have this third translation. So that means here we are going to have the arrow downwards. Clear? Is it clear to all of you? Now carefully see this. Go further to right. XXW. Then we have this 1. Fine. That means from S we are going to have this translation here. We are going to have this translation here. Then we have SZ. This one. Then we have this third translation. You can number this also. Fine. Let's number this. This is 2. Second translation, and this is your first translation. This is your third translation. Now after that you have SZ third translation. So you are going to have this one. Fine. Clear? So you are going to have this translation here. Any mistake? Okay, sorry, this is third, na? W drives SZ, this is third. Sorry. Let me just rewrite again. This W drives SZ, that is the third translation, right? So we are going to write 3. XXW is the first translation, so we are going to write 1. This one is third, right? And then we have XXW, so again that is 1. So here we are going to have the arrow downwards. So this is your 1. This is your 1. Is it clear? Yes. This is your 1. Now you have the second translation. What it is doing? It is printing 2. So output will be first 2. Then you have third. Third is printing 3. That means it is almost same. First it printing 1. So then we have 3. Then we have 1. So this is going to be the output 23131. Is it clear, everyone? Now if you have any doubt, anyone, please ask. 23131, yes, that is the correct answer. This is the best way to solve this question, and this question we have solved on the basis of L attributed evaluation. And you will observe why it is more simple than your bottom-up parsing. So here we are following this depth first, left to right. Depth first, left to right. Clear? This is easy. Yes, this is easy. If it is not given in the question, then definitely you should solve using this depth first, left to right only. Yes, Vishal sir, please solve using reverse of RMD as well. Okay, let me solve it here. Let me make the tree first. S here, Z here, then we have this X here, and W here, and then we have this S here and Z here, and then we have this Y. Correct? Now we know this in case of bottom-up parsing, we have reverse of RMD. Reverse of RMD. So first what we are going to do is, first we are going to find the RMD order, and then we are going to take the reverse of it. Carefully see this. First of all, first of all, I derived this one if using RMD, rightmost derivation. I hope it is clear what is rightmost derivation. First of all, we are going to derive this one, XXW, that is the first translation. Clear? Carefully understand this. SZ, because after that, this is the non-terminal, right? First, this was the non-terminal, we derived XXW, then this is the non-terminal, so we derived this one, that is SZ, that means the third translation, so we have third translation here. Then, according to SZ, XXSZ, this is the non-terminal, rightmost derivation will be this one only, so we are going to have this one first. Clear? Then we have XXW, in that case we are getting SZ, so this is the next we have derived, this is the rightmost non-terminal here, and this is what, WSZ, so this is 3. And finally we have this one as the rightmost non-terminal, so this is what, S drive, that is 2. So if I write the RMD order, reverse of rightmost derivation order, first it is going to be 1, then it is going to be 3, then it is going to be 1, then it is going to be 3, then it is going to be 2. If this is your RMD order, so what is going to be your reverse of RMD? Just opposite of that, which is 2, 3, 1, 3, 1, that is your answer. Is it clear to all of you? If you have any doubt, anyone, please ask. मजा आ रहा है everyone? मजा आ रहा है? Clear? Which one is easy? Which one is more easier? Tell me. That one is more easier or this one? हाँ, यहाँ पे एक ही नॉन टर्मिनल था तो इसलिए एज सच कोई इशू नहीं है. जब अगर if we have more than one non terminal, always rightmost. Clear? Okay, so let's proceed, and now we are going to see another example. So using SDT we can, first one is easy, yes, always follow first one if it is not mentioned, and yes, let's see this one, infixed to postfixed. So this is the functionality, you can say, of SDT. This is one of the functionality of SDT. Yes, मैं मैकेनिकल से हूँ लेकिन मुझे CSE मैकेनिकल से ज़्यादा मज़ा आ रहा है. Change your branch, change your stream. You have to appear, you should appear from, this, this GATE Computer Science. You should appear for this. Yes, thank you, Kritika. Thank you so much. Fine. So now let's talk about this infix to postfix. That means using SDT, there are many functionalities. We are going to see this one functionalities, one of the functionality here. So here we have this input 2 plus 3 into 4. Now on the basis of this given SDT, we are going to find the output. So it is very simple. Again, you have to make the tree here. So first we need, from E we can derive E plus T. Clear? Then we need multiplication. So we need to use this one. So we can have T star and F. Then from F we can have this num. Right? From T we can have this F also, and from F we can have this num. From E we can have this T, from T we can have F, from F we can have num. Now this num is going to be 2, this num is going to be 3, this num is going to be 4. Is it clear so far? Yes, Vishal. CS, performing well in CS is easier than performing in all other branches. Most probably this mechanical, because the number of students that appearing in mechanical is way more than any other branch. Clear? Now again, you can use any evaluation. You can use depth first left to right, or you can use bottom up parsing as well. That means reverse of RMD. So let's do it. So first of all, depth first left to right. So this is going to be the translation because F drives num. So print num dot L value. That means we are going to print 2. After that, if we go further, then here we have nothing, right? Similarly, here also we are not having any translation. Further if we go, so we are going to get this one, 3. Further if we go, we are going to get, sorry, not this one. Right, so here we are going to get this one, that is 4. Now T star F. So now we are printing star. So just go from here, we are printing star. And then E plus T, we are printing plus. So this one, we are printing plus. So this is going to be the output. This is going to be the output 2, 3, 4 star plus. As you can see, this is an infix expression, and the output we are getting, which is this postfix expression. So this is your 2, 3, 4 star and plus. That is the output. Yes, yes, you can answer. But if it is going to be more complex, in that case, it is better to make. That is their issue. But in case if you are not able to understand whether it is here, I have written it is infix to postfix, right? But if it is not mentioned, in that case you have to make the tree, right? Then you have to find out what would be the output. And one more thing, let me tell you one more thing. Sometimes what they can do is they may shift this print star in the beginning also. Like you can have print star then T star F. They may shift print plus in the beginning and then you can have E plus T. In that case, output will get changed. Okay. So that is why it is better in the exam if you make the tree and then get the correct answer. It will hardly take, maximum 1 minute. Is it clear? Fine. So let's proceed to the next one. Another this functionality of SDT, that is evaluation of expression. Now here we have this same input again, but here we need to find the output of this expression. Okay, here we need to find the output of this expression. So 2 plus 3 star 4. Clear? अरे अगर मैं serious face बना के अगर पढ़ाऊंगा तो मज़ा नहीं आएगा ना, right? And पढ़ाई में ध्यान दो, as Saubhagya said, right? Focus on the question that we are solving. So here 2 plus 3 star 4. Evaluation of expression. Now in these cases, when you have to evaluate the expression, you don't have to make the parse tree. You don't have to make the parse tree. And in GATE 2022, they have asked one question based on this one. So you don't have to make the parse tree. You can directly answer. How? Let's say this. You have this as the input 2 plus 3 star 4. Now carefully see this. We have two operators. One is a star, one is plus, right? One is star, one is plus. Now this is your starting symbol. E is your starting symbol. Now if the operator which is farthest from the starting symbol, that means जो दूर होगा ज़्यादा दूर होगा starting symbol से, the operator which is farthest from the starting symbol is going to have higher precedence than the operator which is closest to the starting symbol. So here we have just two operators. So we can say star is having more precedence than plus. And if star is having more precedence, that means first we are going to evaluate this one and then we are going to evaluate this one. So 3 star 4, what it is performing? It is multiplying the value. So we will be getting 2 plus 3 into 4, that is going to be 12. 2 plus 12, it is going to be 14. So 14 will be the output. Is it clear? Is it clear to all of you? Yes, everyone focus here and solve this question now. Solve this question quickly and let me know what should be the answer. Evaluation of expression. Quickly solve this and let me know what should be the answer. Just on the basis of the concept that we have understood in the previous one. Arey Divya, don't disturb the class, okay? If you want to learn, attend the class. If you don't want to learn, you can leave the class, okay? Fine. Now, what should be the answer? So Bhagya is saying 20 should be the answer. Anyone else getting the answer for this question? Yes, everyone. Okay, Nishu is also saying 20. Sashikala is also getting 20. Fine, let's see this. This is the input we have. So let me write it in a large font. Clear? Now say this. We have two operators here. One is your ampersand, or here you can say this one, star operator. Now this is your starting symbol. So which is having more precedence? The operator which is farthest from the starting symbol is going to have more precedence than the operator which is closest to the starting symbol. So, I'm sorry, this is going to be the precedence order. This is going to be the precedence order. So ampersand is having more precedence than star. Now see this. We have to find the associativity also. Why we need to find the associativity? Because here we have two this hash. Okay, I think there is some okay, there is some change. Wait. Okay, this should be this is not star, this is hash, because here we have hash, right? Fine. Here we have hash. Okay, because in the input we are having hash and ampersand, so just replace it with that. So instead of this we can write hash. Fine. Now see the associativity. So here you can see this is left recursive. You know what is left recursion, right recursion, right? So if this is left recursive, that means ampersand is your left associative. Ampersand is your left associative. Clear? Similarly here, this is also left recursive. That means hash is also having left associativity. Now which is having more precedence? Ampersand. Ampersand is left recursive. So first we are going to solve this one. What it is doing? It is performing the addition. So we will be getting 2 hash, and here we are going to solve this. So 3 plus 5, it is going to be 8. 6 plus 4, it is going to be 10. And then again left associative. So first we are going to perform this one and then this one. As it is performing addition operation only, so 8 plus 2, that is 10. 10 plus 10, that is going to give us 20. Yes, so 20 is the correct answer. Okay, is it clear, everyone? Fine. Yes, both are left associative, na? That's what I have written. Both are left associative here. Clear? Now let's see one more functionality of SDT, that is converting binary number into decimal number. Converting binary number into decimal number. This is the SDT for that. Clear? Let's take one input. Let's say 101. Now I hope you know this. If we have suppose 11 as the binary number, if I want to convert this into decimal, so what to do? 1 into 2 plus 1. So we can perform 1 into 2 plus 1. What do I get? 3. And this is equivalent to 3. Similarly, let's talk about this one, 101. And if I want to convert this into decimal, so what to do? 1 into 2 plus 0. 1 into 2 plus 0. I will be getting 2 here. Then 2 into 2 plus 1. So 2 into 2 plus 1, that is going to be 5. So this is equivalent to 5 in decimal. I hope you know this concept, everyone. Clear? So this concept we have applied in this SDT. So as I told you, in the SDT we have the translation, and in translation you can write anything. You can write entire program as well. Clear? Now let's take this input and let's try to execute this SDT and see what we get as the output. So just on the basis of this 101, let's make the parse tree. So this is your starting symbol N, then we have L. Fine. Then this L can derive L1B. So here we are writing L1. It is not different from the left hand side. It is same, but just to avoid confusion, we are writing L1. It is L only. Clear? So here we have L, here we have a B. Clear? Now this is of 3 digits, 3 bits you can say. So here we have only 2 bits so far. So from L we can get this LB again, right? Now from L we can derive this B also. Now we are having 3 bits. Now B can derive 0, B can derive 1. We need 101. So this B is going to derive 1. This B is going to derive 0. This B is going to derive 1. So 101 is done. Now let's find the output. Yes, you can write anything, De Villiers. And if I'm saying any program, that means you can write anything, yeah? Okay. But in the exam, they are not going to ask you to write these SDT. Everything will be given to you. You just have to answer those questions. And I'm giving you some questions, some previous year questions as homework after this one, so that you can solve it. And in the next class, I will be discussing that. Fine. So 101. Now here B derives 1, B dot D value is equal to 1. So here we are going to write B dot D value is equal to 1. And when B derives 0, then it is taking the value 0. So that means B dot D value will be equal to 0. Similarly here B dot D value will be equal to 1. Clear? Now L derives B. L derives B. In that case, whatever is the B value, you are assigning to L. Whatever is the B value, you are assigning to L. So L dot D value will be 1 because it is assigning the same value. L derives LB. L derives LB. In that case, you are multiplying by 2 to the L value, then you are adding D value. So 2 into 1. So here we can write D value will be 2 into 1 plus 0. What do you get? 2 only. Again, L derives LB. So here you are going to get 2 into 2 plus 1. That means you are getting 5. N derives L. N derives L. Just assign the value to N. So we are assigning the value to N. And what do we get as the final output? That is 5. That is 5. Is it clear, everyone? Okay. Any doubt, anyone? So this is the SDT that we have for converting binary to decimal. Similarly, we can have SDT for anything. We can have binary point to decimal also. Like if we have 101.11, then that for that purpose also we have the SDT. But here I have taken some examples only. So now I am giving you this previous year questions as the homework. So we have this question from GATE 2019 first. Then we have this second question. This is the third one. This is the fourth one. So I hope you will be able to solve all these questions easily based on the concepts that we have learned in this class. Is it clear, everyone? Thank you so much, Kiritika. Thank you. Guys, do share these sessions as much as you can in all your Telegram and WhatsApp groups so that those who are not aware of these sessions, they can also take the benefit and they can also prepare well for the GATE exam. Okay. So this is going to be the link for my Telegram group. You can join this. You will be getting the PDF of all my technical classes, doubt clearances and guidance. And for more such classes, so tomorrow we are going to start this ICG, intermediate code generation. Before that, we will be solving those 4 questions as well. Clear? Those 4 previous year questions. And then at the end, we are having this liveness analysis class, and the timing is going to be 10 PM for that class. Okay, the last class. Fine. So do subscribe to BYJU'S Exam Prep YouTube channel if you haven't subscribed yet, so that you don't miss any updates, any video that we are posting, and also that the sessions that we are taking for your benefit. Okay. So thank you. Good night. Take care and bye-bye. Thank you all. All the most important concepts I have covered in this series. Vishal. Okay. Good night. Take care and bye-bye. Yes, Kirutika, I will be sharing that. I will be sharing the answers in the group. Okay.